Right. So we have seen a couple of days about SD-WAN. We have a lot to cover actually, but let's quickly have a revision of what we have learned, and then we'll get into something new today. Software-defined wide area network allows us to have a centralized management, provides us the secure communication between the edge device, reduces the manpower. We don't need to go to various sites to configure. All we do it from one single point, single place, using the controllers. And when we speak about controllers, there are three different types of controllers. One is the vManage, the other one is the vBond, the other one is the vSmart. vManage provides you the GUI, using which we configure the policies for our edge in various parts of the world, various sites. So using vManage we configure, and this vManage pushes the policies, the configurations down to edge devices, straight away to the edge devices, some through vSmart, using netconf. We have vBond for authenticating the edge device, and we have the vBond to provide the manage and the vSmart location to the edge device that newly joins the SD-WAN fabric. These are the roles of this controllers. vBond's role is to authenticate. After that, to the edge device, it provides the location of the vManage and vSmart, using which the edge device will go and talk to the vManage and vSmart, from where the configuration is downloaded. And now the edge devices, using the configuration that is downloaded using netconf, or in another way, the vManage and vSmart has given the configuration for the edge device, using which it builds the control plane. This control plane is distributed through the vSmart. In another word, the route is advertised to all the edge devices through the vSmart, using a protocol called OMP, Overlay Management Protocol. That is how all these edge devices learns about their LAN network and the reachability to the remote LAN networks behind the remote edge, the route policy, etc. So the edge devices, they advertise. Not straight away they can advertise, because SD-WAN is an overlay concept. It needs to be advertised via the tunnel. We are talking about a virtual topology on top of a physical topology. Physical topology is the the WAN connections, the internet, the MPLS, over which a tunnel is now established between the edges. Through the tunnel, using OMP, the vSmart advertises the route information for the routing table to all the edge device, using which the edge device can move their packet from their LAN to the remote LAN over the circuit, over the IPsec tunnel. So between this edge device, there's going to be an IPsec tunnel. This is one of the big advantage of SD-WAN. You see, you got security. Always you got secured communication, for which we did not configure IPsec or DMVPN. We got security. We got reliability, because edges are not simply added to SD-WAN. Edges are first authenticated using vBond. After verifying the certificate, only then edge device can become a part of SD-WAN. After then only the edge devices receive the necessary route information via vSmart. So this vBond authenticates by checking whether the edge device is in the whitelist. vBond should have the edge device serial number, the chassis number in the whitelist. This whitelist model provides more security. So certificate plus the whitelist together provides double security only for those devices that is identified as secured and listed already in the whitelist, for which the certification is the certificate is matching. The access to reach, manage and vSmart is provided, through which the edge devices go and talk to vManage and vSmart. We also learned about the other two protocols. Let me remind you. TLS and DTLS. Hope you remember that. I'm not going to go deep into it. We have discussed on TLS and DTLS, which is forming tunnel in between the vManage, vBond and vSmart. And initially the edge device also uses DTLS connection to vBond. All these things we spoke. Also we learned about, we also spoke that these controllers can be on premises using ESXi or KVM, or it can be on the cloud anywhere, maybe on the Cisco controller as a service cloud, or it can be on the Google or Microsoft or Amazon. Now, edge device, WAN edge is the right word, because we also have Cisco edge and WebTel Edge. To simply say edge, it is appropriate to say WAN edge. It includes both WebTel Edge as well as the Cisco Edge. This edge device is zero touch provisioning. Can get added to our fabric with no configuration. Just take the box, plug into the power outlet, plug the network cables, the WAN and the LAN cables. That's it. All other things are automated. We're going to go deep into this automated edge provisioning in some time. So let's go next. The edge device can be a VM if you are using CSR 1000, but mostly the edge devices are all physical device. I have shared the PDF for you to see various series of WebTel Edge and Cisco Edge. We spoke about the VPN. VPN are nothing but VRFs. There are 16-bit reservation for this VPN. So you can have 0 to 65535, in which VPN 0 is for the transport, it's for the control VPN. VPN 512 is for the out-of-band management. Other than these two numbers, 0 and 512, you can use any other number for the tenants that you create. Each tenant you may provide a separate VPN, separate VRF. So every VRF is unique because it is going to have different number. Every VPN is unique. Now, what is this out of band management VPN? See, you may like to telnet to vManage or vSmart or vBond or the edge devices in various sites, telnet or SSH, which is not in between edge device. It is from a management network to this controller, or from this management network to the edge device. It is not between the edge device, so it is out of band. It is when it will be called as in band when it is between the edge device. When you are telnetting between the edge device, then it is in band, meaning it is going through the SD-WAN VPNs, then it is in band. But this one is out of band because this is using just the internet to, it is using the underlay, not the overlay. It is using the underlay to get the SSH session with the edge device or with the vBond or vManage or vSmart. So it is out of band. That's why you see they have drawn like this, a separate circuit which can directly talk. It's not going through SD-WAN tunnels. Just simply using basic network IP reachability. So the service VPN or the transport let's finish this. I said we can have 65535 from 1 to 65535, in which 0 and 5 and 2 is already reserved, we should not use. I said that but this is the last usable VPN. So from 31 to 35 we cannot use. Not allowed. Fine. Next is, other than the data VPN, all other things are service VPN. Service VPNs are the management traffic going tunnel service VPN, for which number 0 is given. Only one VPN with a base license you can have. If you want to have multiple VPNs, then we need to purchase the license. And we learned about this protocol OMP. The OMP is the protocol that is the reason behind distribution of the route information between the edge devices. The route information as well as the Tlog, transport locator route. Please try to understand this. OMP routes are nothing but the route distribution of one edge to the other edges. The networks of one edge is advertised to other edge with the next hop address, that is OMP routes. Tlog routes is nothing but, say, transport locator. Who is going to be the transport here? The internet, the MPLS, the WAN. Over this internet, over this WAN, you're going to form a path, a virtual connection, a path to reach the remote edge devices. Sometime you may be forming a path via MPLS, sometime you may be forming a path via internet. So here is our edge device. There's another edge device. Now this Tlog is the information that says that this edge device will, though it is connected via MPLS, internet, even though it has got two VPNs, IPsec connection, between edge 1 and edge 2, how many connections is there? There are two connections, two IPsec tunnels. Even though we have two IPsec tunnels, we will not be using both the tunnels all the time. Depending on the policy. What is policy? It is mentioned in this Tlog itself. We call it as color. Depending on the policy, depending on the quality of the path, the edge device may use MPLS to reach the other edge. So these information, whether to go via MPLS or to go via internet, the Tlog route information got the next hop address. So the elected path, see, these are the information the Tlog route advertises using OMP. What? You should go via MPLS tunnel in order to go to edge 2 if it is a voice traffic. If it is a data traffic, you need to use the internet to reach the edge device. This is what called as color. This is what called as Tlog routes. OMP routes is the route that is showing all possible paths to reach the remote LAN, remote edge to LAN. All possible routes as per the policy, but we may not be using all the routes for different type of traffic. We'll provide different type of services, different priority. That is what we see in Tlog. We see system ID. What is system ID in Tlog? To go to edge 2. Edge 2 is a system ID from edge 1. To go to edge 2, go by MPLS. That's the color. That's one of the information in Tlog. And you should use IPsec, not GRE. That is also carried in this Tlog. Service chaining is while you go via MPLS tunnel, you have to go through ASA firewall. That is what called as service chaining or service route. So all these informations are carried using this OMP protocol. To verify, we can use show OMP peer, show OMP route, show OMP Tlog, transport locator, show OMP services. See, we have something called organization. In the certificate, we may use this organization to evaluate. If the organization matches with the SD-WAN controllers in the certificate, then it is validated. Organization is an identifier that is common for all the devices. So in a company, definitely this organization, it will be common for all the devices. That is one of the parameter that needs to match during the authentication time. So it is configured on each device. We got two different type of certificate. One is organization based certificate. The other one is the certificate which comes along with the device pre-installed. If you don't want to use a certificate which is pre-installed, then we need to configure a certificate which belongs to the organization manually on every device, so that the devices can be identified as one common SD-WAN group. That's where the organization comes into picture. Next is site ID. See, sometimes we may have multiple edge device. This is our site. Site 1. We got two edge device, and this is our LAN. Not just one edge device, we have two edge device. Now both the device need to be identified with a unique number, so that, see here it is connecting to the WAN. This is MPLS, this is internet, every edge device need to establish a tunnel via all the WANs. That's why we have a full mesh connection. So here is another site. So site 2 should see both these edge device are from one single site. Site 2 should see these two as one single site, not two different sites. For that we need one common numerical identifier. So that there won't be any VPN tunnel between these two. Look at this, they are in same site. You cannot have IPsec between these two. How you know that this is not from different site? How you know this is not from different site? Because the site ID is same. Because the site ID is same for both, we don't form an IPsec between this. The remote site also, because the site ID is same for both, the remote site also see these two as one single site. So site ID is important. The numerical number that identifies the site ID is a numerical identifier that allows SD-WAN to group devices to each other. So this two forms one site because it has got same site number, whereas this one is having different site number. So that helps us helps the devices to know how many sites we have in this SD-WAN group. Not only that, it is used in the SD-WAN policy to configure the characteristics associated with the location. This has got one site, so policy will be common for both edge device. So site ID is another important thing. Organization, site ID, system IP. This is the IP address using which we identify the devices. This will be unique for every device. In my previous example for site ID, I was having two edge devices. Both the edge device will have same site ID but not the same system IP. System IP will be different. System IP should be unique. It is same like the router ID in OSPF. It uniquely identifies each devices, the controller and the WAN edge devices. Every device will have a unique IP address. It need not to be a reachable address. Same like OSPF router ID. Even if you don't ping the OSPF router ID, even though it is not configured on any interface, it can be used to identify the device. Same way, third point, although it is the form of an IP, it is only used to identify device. Identifying the device is one of the component in Tlog. In Tlog we have three components, right? One is system IP, which is nothing but the identity, the router ID, the system IP. First we need Tlog. In Tlog we need your first system IP. Where am I going? And then color, via which I am going. Am I going through MPLS or I am going to go through internet? That is color. Third in the Tlog is how I am going. Am I going encrypted using IPsec, or am I going to use the normal internet. See, color is nothing but tags. See, when we have two WAN connection, then we will have two tunnels established from each side. So we may choose internet as an option for some traffic. For some traffic, MPLS as a option, WAN option. So those traffics need to be tagged, saying you need to use MPLS. So how do we do that? We put a color, we put a tag. So this is another component in the Tlog, transport locator. Here comes the final, the Tlog itself. Tlog, it is an identifier that needs as a next hop in the OMP. As I said, based on the tunnel, based on the tag, the next hop is going to be determined. Because we may have more than one next hop, one via the MPLS, one via the internet. Which next hop to take for this traffic, that depends on the tunnel. So one Tlog per WAN circuit. Means for MPLS you got a different next hop. For the system IP is same, but the color is not same. For some traffic it is via internet, for that there is another next hop, so there is another Tlog. Now when we forward the traffic via multiple WAN connections, we can have up to 7 WAN connections. We can have up to 7 WAN connections, and we can load balance the traffic in these 4 different ways. You can use all 7 as active link, or we may have all 7 but not with equal priority. We give different weightage. All are active only, all are going to be used, but first which one to use, second which one to use, third which WAN to use, that depends on the weightage. Fourth, there's a third way of traffic forwarding, that is application pinning. So we just pin the applications to different WAN path using the tag in Tlog. Accordingly the traffic will go. So in which all other paths are going to be standby. The fourth way is applications are going to use different paths as active based on the SLAs. SLAs can be IP address, based on IP address, or QoS values, or the MAC address, or the port number, or the protocol. Sorry, not the MAC address. It may be based on the layer 3 protocol, or the layer 4 port numbers, or the IP address layer 3, layer 4 protocols, or QoS. It can be any of this or all of the 6 tuple match, like an access list. But if you have a special application license to do deep packet inspection, we can also match traffic using the layer 5 to layer 7 class maps kind of deep packet inspection. Based on the deep packet inspection, we may choose different path. So you can have up to 7 WAN paths. Load sharing can be, you see all 7 paths as equally preferred path. That's the first option. Second option, based on the weightage. Third option, we want active for some, standby for the other. For that you may do application pinning, or you may also do based on the SLA. So during the runtime it will determine based on the SLA where to forward, which WAN paths to take. So this is where we stopped in the previous class. Let us move on to the new portion of SD-WAN. I have not documented in the presentation, so I'm going to write coding. What we are going to see next is how the edge devices automatically joins our SD-WAN fabric. I can name it as automated edge provisioning. Automated edge provisioning. Just you plug the edge device and the device automatically discovers the V bond. The IP address of the V bond. It knows the IP address and then it goes get authenticated, and the provisioning process starts with the V bond. How is this possible? You just we are in a different part of the world. We buy the edge device and we connect to the existing WAN, and our edge device automatically discovers the V bond and goes for authentication. Once V bond authenticates, it goes and handshakes with vManage and vSmart. How is that possible? It is possible in two different ways. One, zero touch provisioning, which is by Webtailor itself. The other one is PNP, plug and play. Plug and play connect, zero touch provisioning. Right, as I said, zero touch provisioning is for all the Webtailor edge device. Plug and play is by Cisco. Obviously it is for C edges. Now, what about the virtual router? You remember we have one virtual edge device. For so virtual routers cannot be part of ZTP or PNP. So please understand, it needs to be a physical device for automated edge provisioning. For virtual device, we need to add the necessary IP address information and so on to the bootstrap. We'll talk about that later. So what I want to say here is the zero touch provisioning, or this PNP, plug and play, is only for hardware edge device, not the virtual edge device. Not for the virtual edge device. Now, there's a prerequisite for this. What is that? The edge routers must be getting an IP address, the default gateway, and the DNS from the ISP. That is what the prerequisite. You see, we got WAN connection. we got a edge device. Sorry, edge device. And this is that new site that we are talking about. Sorry, what happened? This is the new site. Newly added edge device. New edge. For this to identify the vBond, first it will identify, it needs to go to vBond. No, vBond is somewhere in the internet, somewhere. We don't know. It's somewhere. The edge device really don't know. It don't have any idea. It's a new edge device. It has got no idea where the vBond is. But it can know by itself. Automatically it can discover the location of vBond. How? For that, the prerequisite is this edge device needs a DHCP support. So this is pre-configured as a DHCP client, okay? This is pre-configured. The edge devices are pre-configured as DHCP client. So what happens is, as soon as you connect to the WAN 1, it starts providing the three information: IP address, the default gateway, and the DNS. If you get only these infos, that's more than enough. That will help to discover the bond. How is that possible? See, I have given you a clue, DNS. See, you got an IP address for your own, and with the help of DNS, you can now go and resolve a domain name. That domain will provide the info of vBond. I'll explain you in detail now. You see, as soon as this one receives an IP address, the gateway and the DNS, it uses DNS address to resolve. If it is WebTrailor device, it will resolve this one, zdp.webtrailor.com. Using DNS, it will go to this domain. It will go to this domain name server. And download the vBond connectivity information with certificate. Understand? The edge devices are not going to directly talk to vBond. It has got no idea where is vBond. But these edge devices, when you purchase, it is pre-configured with this domain name. If it is Cisco device, it is device helper .cisco.com. If it is Cisco C-Edge device, you will have this one, device helper .cisco.com. If it is WebTrailor device, you will have ZTP, zero touch provisioning webtrailor.com inside. As soon as you get an IP address and the DNS, it goes and resolves the location of this domain server first. And let's say that the domain is here somewhere. It goes to the domain using what? HTTPS. Using HTTPS. And this domain name server, after checking the serial ID and chassis number of this new edge device, it pushes, or I can say the edge device downloads the VBON connectivity information, meaning it gets the location of the VBON. With the certificate. The certificate comes along with the hardware. You may have an organization. Now the organization certificate needs to come from the Webtail or Cisco. If you're going to use an org, a separate certificate. So the plug and play portal, this is the plug and play portal, right? Cisco. The plug and play portal is configured earlier to provide informations, meaning we are adding the device to plug and play portal software.cisco.com by providing the serial number and the chassis. Yeah. So VBond will now authenticate the edge device. The edge device now knows the location of VBond. It goes to VBond. VBond will now authenticate by checking the certificate. How VBond knows the certificate? VBond gets it from vManage. How vManage knows? We configure the vManage by downloading the file from the portal. Please understand. The edge device goes to the portal. Now you will be allowed to download a provisioning file. You take the file and put it in the vManage. Now with the certificate and the location of the VBond that is downloaded, it will go with the certificate to the VBond. By the time VBond is ready with what? A whitelist saying that there is going to be edge device coming to me, I need to authenticate. How VBond knows that? vManage knows. Who gave to vManage? We gave the vManage information using the provision file that got downloaded from the portal. How portal gives you the file? By checking your chassis number, by checking your serial number. So portal gives you the provisioning file, put the provision file to the vManage. Now, you can also do automatic synchronization. This vManage, you don't need to put the provision file every time. You can automatically sync with this portal. So that we need not to download the provisioning file for every edge device. When a new device is coming and talking to the portal will automatically send the device information to vManage, and vManage will put it in the whitelist As the device goes to vBond, vBond will authenticate. See, this is how the zero touch provisioning happens.